will increase the refractive index of the prism, you will increase it. Then angle of deviation, del will also increase. Angle of deviation, del will also increase. If you will increase the angle of the prism is this angle. If you will increase, then also the angle of deviation will increase. Then also the angle of deviation will increase, because these are the result from the experiment. If you will see from this formula, then it will look like this result is incorrect. Means how the angle of deviation is depending upon the wavelength. If you will increase the wavelength, angle of deviation will decrease. So sunlight have 7 colors. Sunlight, or you can say white light, have 7 colors.
Yes,
violet, indigo, blue, green, yellow, orange. So the violet color have the minimum wavelength. Violet color have the minimum wavelength. And red color have the maximum wavelength. So I told you that if you will increase the wavelength, angle of deviation will decrease. So you can say that angle of deviation will be less for the red color than the violet color, because the wavelength of the red color is greater than the violet color.
Yes, sir.
Now there is a graph between the angle of deviation and the angle of incidence. There is a graph between the angle of deviation and the angle of incidence. If you will draw the graph, at some point you will get that there will be one minimum deviation. So suppose here you are getting, at this particular angle, you are getting the minimum deviation. You can see this line.
Yes, sir.
The minimum deviation. This is minimum deviation. So this is I. This I becomes equal to E also at this point. This I becomes E also at this point. One more thing, if you are taking any other value of del, that is del 1 you are taking, then there are 2 values of angle of incidence. There are 2 values of angle of incidence. Okay, so one value you will get from here, another value you will get from here. Suppose this is I1. At I1 you are getting del 1. There will be another value of incidence, that is suppose this is I2. For I2 also you will get another value of del 1, same value as del 1, but you will get the minimum angle of deviation for only one angle of incidence. Okay. So this graph is not a parabolic graph. So this graph is not a parabolic graph. So this is not symmetric graph. So if you will take this distance as x, and if you will take the distance as y, so you will say y is greater than x. So that is why this graph is not symmetrical. So this graph is not a parabolic graph. Angle of deviation is minimum for one value of angle of incidence. So you have to remember this thing. After that, we have this problem. Refractive index in terms of the minimum angle of deviation. So whenever, suppose this is a prism and this is a ray of light and it is making an angle of 30 degree with the normal. So for this ray of light, having the angle of incidence of 30 degree, have the minimum angle of deviation.
Yes,
sir. Ray of light is deviated minimum when the angle of incidence is 30 degree. At the same time, when there is a condition of minimum deviation, then angle of incidence and angle of emergence becomes equal. So this 30 degree and this angle of emergence will also be equal to 30 degree. Now this R1 and R2 also becomes equal. This R1 and R2 also becomes equal. Okay. So note, when the angle of deviation is minimum for any value of angle of incidence, then you can say angle of incidence in that case becomes angle of emergence, and R1 and R2, the value of R1 and R2 becomes equal. Okay.
Yes, sir.
both values become equal, and mu is the refractive index of the
prism.
refractive index of the prism. Now we will derive that formula. We will derive that formula. So they are saying relation between the refractive index of the prism,
Angle of prism and minimum angle
of deviation. So there is a ray of light, suppose here, like this, and this ray of light is going. We have to draw the normal here. It will bend towards the normal first, and after that it will bend away from the normal. Will bend away from the normal. This angle is angle of emergence. This angle is angle of incidence. This angle is angle of prism, and refractive index of the prism is mu, and this angle is R1. This angle is R2. Here we are talking about the minimum angle of deviation. Means del becomes the del minimum. Del becomes the del minimum. So if this is the condition, then I must be equal to E, and R1 must be equal to R2. Let us suppose this is equal to R. Let us suppose this is equal to R. Okay. Now there is a relation between A and R1 and R2. That relation A is equal to R1 plus R2. A is equal to R1 plus R2. So now from here, you can find this is A, and R1 is also R, R2 is also R. It will become 2R. So from here you can find the value of R. R is equal to A by 2.
Yes, sir.
A by 2. Or you can say R1 is equal to A by 2. After that, for this ray, if you will find the angle of deviation, that is del is equal to I plus E minus A. This del is this time is del minimum. So this del is del minimum. And we know that I and E both are equal. So I can write this as I, this is I, and E is also equal to I. So I can write here.
Yes, sir.
This become minus A. So it will become 2I minus A. Now from this expression, it is equal to del of minimum is equal to 2I minus A. Find the value of I. So you will get, when you will find the value of I, this is del minimum, this is plus A, you will get del minimum plus A divided by 2. So this is the value of I. Now apply the Snell's law on this surface. If apply the Snell's law on the first surface of the prism, Snell's law. When you will apply the Snell's law, here is air, so refractive index is 1. Here is prism, so refractive index is mu. So you will write 1 into sin I. When you will apply the Snell's law, it will be 1 into sine of I, that is equal to for this medium mu into sine of R1. It will be mu into sine of R1. It is sine I is equal to mu times of we have I na, I we can put this value. Sine of I na, I we can put del minimum plus A by 2, or you can say A plus del minimum by 2. A plus del minimum divided by 2 you can put, and here is, you can write refractive index mu sine of R1. What is the value of R1? A by 2.
Yes, sir.
You will get A by 2. So mu from here you will get mu is equal to sine of A plus del minimum by 2 divided by sine of A by 2. So this is the formula that is used in that question that you were asking. Okay, now we will try to solve that question. First you can note down, then we will discuss that.
Yes, sir. Sir, what's angle of deviation called? The sign? Del, right?
Del.
Yeah. Second scroll. Then, sir.
So for this particular angle, suppose I have just taken the example for 30°, this ray of light will go minimum deviation. That is why this 30°, also the angle of emergence is also 30°. Okay.
Yes, sir. So, yes, sir. So you can scroll down. So you can scroll down.
So do you have right now that question? Please open that question. Now we will solve the question that based on this.
Yes, sir.
But directly related to this derivation. Completed?
Yes, sir. So which one? I have sent you 2 questions.
Question number 3, an equilateral glass prism. This one. First we will solve this.
Oh yeah, okay.
We have no? So first
Yeah.
read this question.
An equilateral glass prism has a refractive index
of 1.6 in air. Means
calculate the angle of minimum deviation of prism when kept in the medium of refractive index.
Refractive index 4√2/5. So
Yes.
basically here now we have done this derivation. We have assumed here on both sides of the prism there is air. Okay, on both sides of the prism there is air. All the conditions will remain same. All the conditions will remain same. But they are saying in air the refractive index of the glass prism is 1.6. Okay.
Yes, sir.
Means the absolute refractive index of the prism is given. Absolute refractive index of the prism is given as 1.6. With respect to the air, I told you that the refractive index is absolute refractive index. But now this prism is kept in a medium of refractive index 4√2/5 means surrounding this surrounding medium of the prism now having the refractive index 4√2/5. Okay, 4√2 divided by 5. Okay, 4√2 divided by 5. Now from this step, see from this step, when we are applying the Snell's law on the surface, now apply the Snell's law on the surface again. In the solution, na, they have not done completely. Means they have just divided it so that means they have taken the directly the refractive index. Okay, Snell's law you will apply now. So when you will apply the Snell's law, so how you will now apply the Snell's law? This refractive index multiply I. Okay.
Yes, sir.
Refractive index multiply I. So that is refractive index of surrounding multiplied by sine of I is equal to refractive index of this medium, that is 1.6, or that is refractive index of the prism multiplied by sine of R1.
Yes, sir.
R1. Now what is the value of mu s? 4√2 divided by 5 sine of I. Now see, all the things will remain same. Okay, all the condition of the minimum deviation will remain same. So I we can put from here del minimum plus a by 2. Okay, so we can put sine del minimum plus a by 2 is equal to Refractive index of the prism is 1.6 given, and
Yes, sir.
multiplied by sine of R1. Sine of R1 is R by 2. Sine of R1 is R by 2. A by 2, sorry. Sine of R1 is A by 2. A by 2. Now this question is finished. Now see, they are in the question. See, this is written there, equilateral prism. If the
Yes,
prism
sir.
is equilateral, the angle of the prism is 60 degree.
Yes.
We have also done this type of one question, I think. Equilateral type of prism is there.
Yeah, we did last class.
Equilateral prism, angle of prism becomes 60 degree. So 60 degree. Now, so in terms of A, you will put 60 degree. So it will become 4 root 2 divided by 5. Sine of del minimum you have to find, and A is 60 degree, and this is divided by 2. This is equal to 1.6, and this is sine A by 6. A by 2 means 60 by 2 means 30. Means 30. So here you will have 4 root 2 by 5. 4 root 2 by 5. 4 root 2 divided by 5. 4 root 2
divided by 5.
Sine of del minimum you have to find plus 60 degree divided by 2, and this will be 1.6 multiplied by sine 30 is 1 by 2. Sine 30
Yes.
is 1 by
2.
So you can just solve it now. So it will become 4 root 2. It is better to take all these this thing on the right. So you will have sine of del minimum plus 60 degree divided by 2 is equal to 1.6 multiplied by 1 by 2 multiplied by 5 divided by 4 root 2. 5 divided by 4
root 2.
Okay. Divided by 4 root 2. So when we will solve it, we will get here, we will get 10 when we will remove it. So here we will have 5 2s are 10. Okay. And here we will have 4 4s are 16. And here we will have 2 2s are 4. And this 2 and 2 will be cancelled out. What is happening? Are you getting now? This is just a calculation.
Yes, sir.
Finally, you will have 1 by root 2. So finally, you will have 1 by root 2. So this is sine del minimum plus 60 divided by 2 is equal to 1 by root 2. And 1 by root 2 is sine 45 degree. We know sine 45 is 1 by root 2. This sine of this angle is equal to sine of 45. Means this whole angle must be equal to 45 degree.
45, yes.
Del minimum plus 60 divided by root 2 is equal to 45 degree. Divided by not root 2, this is 2. So this will become 90 minus 60. Answer will be, I think, 30. So it will be 2. So del minimum is equal to 45 multiplied by 2 is 90, and minus 60. Your answer will be 30 degree, I think. Check the answer.
It is it is 30 degrees.
So this is the proper way to calculate the answer. Otherwise, if you will write the relative refractive index, means the refractive index of the prism divided by the refractive index of the surrounding, then you will write the formula sine of A plus del minimum by 2. I can do in this way also, sine A by 2.
Yes.
You will not get whatever. So in this way also, if you can solve, if you have the knowledge, then I think it is better way to solve. Like if you want to write down this, then you can.
Yes, sir. I write down this.
So in the next question, means it is from the astronomical telescope. The concept of similarity of triangle we will use.
Yes.
Similar triangles. The ratio.
Second, scroll down.
Scroll.
Done, sir.
Okay. So ray diagram I will discuss in the class, in the upcoming classes, after 1 or 2 classes we'll discuss that, but I'm just discussing the numerical part here. So that is a real problem here. So in telescope,
Yes, sir.
Two main things are there. One is objective lens. Objective lens. Objective lens means the lens of the telescope, and there is one eye lens, that is our eye has the lens, na?
Yes, sir.
Our eye has the convex lens. Okay, so this is the objective lens of the telescope, and with the help of this telescope, they are saying a giant reflecting telescope at an observatory has an objective lens of focal length 15 meter.
Yes, sir.
This has the focal length of 15 meter. This lens has the focal length of, suppose here is somewhere focus, and this focal length is f0, and focal length of objective lens is 15 meter. Okay. After that, they are saying and eyepiece of the focal length of 1 meter. Our eye has the focal length of, means the eye lens has the focal length of 1 meter.
1 meter.
1 centimeter. 1 centimeter. Sorry. If this telescope is used to view the moon, you are watching the moon through this telescope, through the lens of this telescope. Find the diameter. They are asking. Find the diameter of the image of the moon. Diameter of the image of the moon formed by the objective lens. Okay.
Yes, sir.
The diameter of the moon is this, and the radius of the lunar orbit. So diameter of the moon, the diameter of the moon is the diameter of the moon, and radius of the lunar orbit means the distance between the Earth and the orbit of the moon is known as the, okay, the distance between the Earth and the moon is known as the radius of the distance between the center of the Earth and the moon is known as the radius of lunar orbit.
Lunar.
So you are watching, suppose here somewhere is your moon. Okay, here somewhere is your moon. So we'll draw one straight line like this. Where is your moon? So this moon is at a height of, suppose, h. So this is moon is an object, na? We want to see.
Yes, sir.
This moon is the object we want to see. So we will take height of object. Now for this object, the image will be the inverted image. Okay. In astronomical telescope, the image is formed, and you are watching this from here. Suppose from here you are watching, and the image of this is forming, suppose, here. Okay. So this height will be the height of the image of the moon. And this distance you can take x, y, z, anything. Means what is this distance? This distance is distance between the objective lens, and where is the objective lens? On Earth. And there is the moon. So this is the distance between the Earth and the moon. So you can just call it x. Okay, call it x. Now, what you have to do, you have to use the similarity of triangle to solve this problem. Very simply. Basically, it will be like this, okay? Height of the moon will be, height of the image of the moon will be like this. So now, do you know what are the similar triangles?
Yeah, congruent triangles, right?
Yeah, similar, congruent is also similar, but in similar triangle, ratio of the corresponding sides are equal.
Equal, yes.
If you will say this angle is 90 degree, then for this triangle, this angle is 90.
90 degrees, alternate angles.
If this angle is theta, this angle will also be theta because vertically opposite angle.
Yes, sir.
Now, third angle will automatically equal to the third angle of this. Okay, so that is why this triangle and this triangle will be similar. So from here, you can just write the ratio of the corresponding side. Means height of object divided by height of object divided by height of the image. Okay, height of object divided by the
height of image.
Height of image. Okay, you can write is equal to x divided by
f4.
So you can write height of object. You will take first side of this triangle.
Yes, sir.
Perpendicular of side of that triangle. Perpendicular of this triangle. And height of image is equal to, you will take x and divided by f naught. Divided by f naught. And you have to find the diameter of the image. Means height of the image you want to find. Height of the image you want to find. Okay.
Fine.
Height of the image you want to find. You can find is the height of object will be radius of the moon. What is the radius of the moon? Just tell me.
Radius of the moon.
Okay. So tell me the radius of the moon, and we can just convert it in terms of HI. So
yes, sir.
I can convert it in terms of HI because HI we want to find. It will become f naught divided by x. So from here, HI you
sir,
will take,
radius of the moon is 1007 kilometers, right? Something like that.
No, we will take according to the question.
Oh,
It's given in the question, na?
So sorry, sir. I don't have the question right now.
Okay, you do not have. Okay,
like the book is there.
I am having. So diameter of the moon is 3.48. Basically, this height of the object, they are taking the diameter of the moon.
Yes, sir.
FO is 15 centimeter.
Yes.
Now height of the object is 3.48. 48, yes. 10 to the power 6. 10 to the power 6. And divided by, what is the radius of lunar? Radius of lunar orbit 3.8 into 10 to the power 8. 3.8 into 10 to the power 8. So this 3.8 cancel out 3.48, na? This 3.48 and 3.48 will be cancel out. So here you will have
15 into 10 to the...
Oh, actually, na, this is a 3.8 and this is 3.48. This is not 3.8. This is 3.48. 3.8. Yeah. 3.8 here. So when you will cancel this out, na? 3.48. 3.48 10 to the power 6. So you will have 15, and when you will just calculate it, so it will become 10 to the power minus 2. This is 10 to the power 6. This power will go in the numerator, so it will become 6 minus 2. It will become 10 to the power minus 2. Okay, and this value 3.48 multiplied by 3.8. So when we will calculate, we will get approximately 0.13 meter. You will get 0.13 meter, your answer. And when you will multiply it, na, 0.137, I think you will get in meters, you will get answer. Okay. And when you will just, we know that in 1 meter, how many centimeters are there? 100 centimeters.
100 centimeters.
100 centimeters. If they are asking in the centimeter, na, so your answer can be height of the image, na?
Yeah. You just multiply the thing with 100.
Yeah, multiplied by 100. It will be 0.137 multiplied by 100.
100.
Your answer will be
137.
approximately equal to
137.
7.0 centimeter, approximately equal to, you can say 13.7. Okay.
Yes.
This is also right answer. Just please write down.
Yes, sir. Yes.
So you have to remember here we are using the similarity of the triangle concept. Similarity of one.
So did you check the paper?
Sorry, actually, I have not checked yet. I will check in a few days.
Okay, sir.
But these days I am having large number of classes. Due to that, I am not able to. Most probably, I will check this Friday.
So hold on. Done, sir.
Okay. So now we will discuss the refraction from spherical surfaces. Refraction from the spherical surfaces. Till now, we have discussed the refraction from the plane surfaces. Now we'll discuss the refraction from the spherical surfaces. So this is a spherical surface. This is a spherical surface. So there are few points here that already we know. All distances we will measure from the pole. So this is the pole. This is the pole.
Yes, sir.
So all the distances we will measure from the pole, and distance measured in the direction of the incident light is positive. Okay. So if you
Sir, in the last question, tell me, what is the name of N?
What is the name of
N?
Oh,
In
refractive
the last
index.
question. No, N. It's new, right? Refractive index is new, right?
Oh, that thing is mu. That is not N.
Yeah, I was like confused. Like N.
No. Just you can ask me. No, you means like this. This is N is something like that. This is N.
Yeah.
This is mu. So remember, refractive index we represent with mu.
No, sir. In the next question, like the this one.
In
This
the
one.
in this one,
not this one.
this
The next one. Yeah,
this
this one.
This is
Yeah.
X. This is not N. Sorry, this is X. I write X like this. Okay.
Okay. So what
You
is
can take
X?
this. You can take this N also. No problem. Your answer will be considered as correct answer.
So what do we call X, sir?
So I write X like this, sometime like this, sometime like this. I do not know, but correctly the X is like this, and is not.
What is the denotation of X? Like what does it
Oh,
mean?
this X is the radius of the lunar orbit.
Okay.
I told you,
Got
na,
it.
this
Yeah.
you are watching. This is the moon, na? Here is the moon,
Yes.
and you are on the earth because you are watching
Yes.
the moon from the earth. So means
Yes.
x is the distance. X the distance between the moon and the
And
center
the
of it.
object. Yeah. Okay.
And the object,
Got
you
it.
can say objective.
Yes. Yes. Got it. You can continue.
So refraction from the spherical surfaces. So N1 and N2. Now here I have taken N1 and N2. N1 is the refractive index here of this surrounding medium, and N2 is the refractive index of this medium. Okay, we will discuss later. So basically this formula we will get, and thing remember here, you should remember all distances we will measure from the pole, and distance measured in the direction of the incident light is positive, and against it is negative. Against it is negative. So for example, I am placing one object here. This is the object, and this is a spherical surface. So this will have the center of curvature also. So C is the center of curvature. So here is
Yes,
the
sir.
object place. Here is the object place. So now from this object, suppose the light ray is going like this. From this object, suppose the first light ray is going like this, and we will draw the normal for this. We'll draw the normal. Normal will be like this. This is the normal. I told you na, in the spherical surfaces, the normal passes from the center of curvature. So this is the center of curvature of this spherical surface. This is the normal. Okay, Harsh?
Yes, sir.
This is the normal. So this angle, suppose, is θ1. Okay, and finally, this is the incident ray. This ray is going in this medium. And after refraction, suppose N1 is the rarer medium, N2 is the, means this medium is the rarer medium, and this medium is the denser medium. So that is going from rarer to the denser, it will bend towards the normal like this. And another ray from the object is suppose like this. Normal incidence. And normal incident is a straight, means light ray will travel straight like this.
Yes, sir.
There will be no deviation. So here both the rays will meet, and here the image will form. Here the image will form. Now mark the distances. What are the distances here? So this distance between the pole and the object is the object distance, U.
Yes, sir.
And you will take negative or positive, because direction of the incident light is this, and you are measuring the distance in this direction. That is why you will
negative,
take
right?
negative. Now, distance between the pole and the center of curvature is radius of curvature. So you will measure this distance like this. So you are measuring the distance in the same direction of incidence. So
yes, sir.
The radius of curvature will be taken as positive. And the distance between the pole and the image is the image distance. And you are measuring the distance in the same direction again. This is the image distance, this distance. That is V. V is also positive here. V is also positive here. Now suppose this angle.
Yes.
This angle is alpha. This angle is beta. And this angle is gamma. Alpha, beta, and gamma. Now from this triangle, from these triangles O, and suppose this point is M. O, M, C. And this angle is, this is the angle of incidence, and here this is the refracted ray, and this angle suppose is θ2. This angle is θ2. So θ2 is the angle of refraction. Now see in triangle O, M, C. Alpha and beta are the interior angle, and θ2 is the exterior angle.
Exterior angle, yes, sir.
When we were driving the minimum angle of deviation for the prism, I told you that the sum of opposite interior angle is equal to the exterior angle. Means you can write for this here theta1 is the not theta2. Theta1 is the exterior angle and alpha and beta are the interior angle. So you can write theta1 is equal to alpha plus beta. Theta1 is equal to alpha plus beta. Now see in this triangle CMI. In triangle CMI, now see this beta is the exterior angle and theta2 and gamma are opposite interior angle. So you can write gamma plus theta2 is equal to beta. You can write gamma plus theta2 is equal to beta. Now from here calculate theta2, that is beta minus gamma. So you have now theta1 and you have now theta2 in terms of alpha, beta and gamma. There are the assumptions here we will take to drive this formula. There are certain assumptions. Assumptions are rays are paraxial. Rays are paraxial means these rays are nearly same.
Yes, sir.
Having a very large distance, very least distance, or you can say these rays are just parallel rays. So means this angle alpha, this angle beta, okay, this angle gamma, and theta2 and theta1 are very small angle. Alpha,
Yes,
beta,
sir.
theta1 and theta2 are very small angle. And there is one more thing that I will tell you later. Okay, so first draw a perpendicular. Draw a perpendicular from here.
Yes, sir.
From the M point, draw the perpendicular on the principal axis.
Yes, sir.
This is the perpendicular, and suppose this point is P dash. And due to that, P and P dash point you can consider same. Mean the distance between the P and P dash is very small. The distance between P and P dash is very small. So
Yeah.
you can just write. You can just write if it is written there that P dash is tending to P. So OP can be written as OP dash. This
Yes,
OP
sir.
can be written as OP dash, and OC can be written as OC dash, OP dash. This CP can be written as CP dash. Okay, this CP can be written as CP dash, and IP can be written as IP dash. This IP can be written as IP dash. Okay. Okay. So now we will find tan alpha, tan beta, and tan gamma from the triangles. So tan alpha, how you will find? Alpha is in this triangle. So see triangle
Yes, sir.
OMP dash. OMP dash. So from the triangle OMP dash, tan alpha is equal to MP dash divided by OP dash. So tan alpha is equal to MP dash divided by OP dash. And I told you OP dash can be written as OP. So we can write OP. And consider this MP dash as H. So this is H by OP. H by. Now see what is OP. OP is U and that is minus U. So H upon minus U. It will become minus H upon U. Now tan beta. Tan beta. So in this triangle there is beta. So tan beta is H upon CP dash. H upon CP dash. Tan beta.
Yes, sir.
H upon CP dash. So H is H and CP dash can be written as CP.
CP.
And CP you can see here is R and R is positive. So you can write H by R. So yeah. Now tan of gamma. This is gamma. So see in triangle M P dash into I. So in this triangle, this gamma can be found out H divided by IP dash. Perpendicular divided by base of this triangle IP dash. H divided by IP dash. It will be H divided by IP dash. Now H is H. IP dash is can be written as IP. And what is IP? IP is V. IP is V. So tan alpha, tan beta, tan gamma you have. Okay. Now alpha, beta, gamma are very, very small angles we have discussed here. Alpha, beta, gamma are very, very small angles. So tan alpha can be written as alpha.
Yes, sir.
Tan alpha can be approximately written as alpha.
Alpha.
So it can be approximately equal to minus h by r. Similarly, you can write for tan beta. Tan beta can be approximately equal to beta, and this is equal to h by r. You can write for tan gamma. It can be approximately equal to gamma. Why this is happening? Because this gamma angle is very, very small. That is why tan gamma can be written as gamma only.
Yes, sir.
So gamma can be approximately equal to this is gamma h by b. So it is h by v. Okay. This is fine now. Now what we will do, we will apply the Snell's law on this surface. On this surface, we will apply the Snell's law. Now apply the Snell's law. And before that, I want to tell you one thing. If theta 1 and theta 2 are very, very small, theta 1 and theta 2 are very small. So theta 1, sine of theta 1 can be written as approximately equal to theta 1, and sine of theta 2 can be approximately equal to theta 2 only. Now
Yes,
apply
sir.
Snell's law. So Snell's law is the refractive index n1 multiplied by sine theta 1. Snell's law. So it is n1 sine theta 1 on the other medium. This is n2. Here the refractive index of this medium is n2 into sine theta 2, angle of refraction.
Yes, sir.
N2 into sine theta 2. So it will be n2 into sine of theta 2. Now I told you theta 1 can be sine theta 1 can be written as theta 1. So you can write n1 into theta 1 is equal to n2 into theta 2. Now see the value of theta 1, alpha plus beta. So put here.
Yes, sir.
So it is n1 into alpha plus beta is equal to this is n2. Put the value of theta 2. So theta 2 is beta minus gamma. Theta 2 is beta minus gamma. Beta minus gamma. So now alpha. What is alpha? Alpha is this minus h by r.
Yes, sir.
Alpha is minus h by r, approximately equal to we have done minus h by r plus what is beta? Beta is h by r only. This is h by u. Sorry, alpha is h by u. This is alpha. Just a minute. I am getting confused. Alpha is see here, minus h by r. Okay. Minus h by r plus what is beta? Beta is also h by r. How can it be possible? Just a minute. We have done some mistake. Beta h by r. It's fine. But alpha is h by minus u. It will be h by minus u. Understanding, hers?
Yes, sir.
Here you can see na h by minus u na we have taken. You can take minus sign here also. H by minus u. So alpha is equal to h by minus u. Okay, it is a alpha that is equal to h by. This is h by u. Beta is h by r. Is equal to n2 beta minus gamma. Beta is h by r. H by r minus gamma. Gamma is h by b. Now h here, from here, and from here, h will be cancelled out. You will have minus n1 by u plus n1 by r is equal to n2 by r minus n2 by v. So now you can take this n2 by v this side. So you will have n2 by v minus n1 by u is equal to n2 by r minus n1 by r. Finally, you will have this formula: n2 by v minus n1 by u is equal to n2 minus n1 divided by r. This is what we are getting. And n1, what is n1? N1 is the refractive index of the medium.
Yes, sir.
From which the light is coming. From which the
The
light
light
is
is coming through.
N2 is the refractive index of the medium in which the light is going.
Is going.
In which
The light is
the light is going. So this is the derivation. Here now you have to apply the concept of the geometry and all that now. Then
Yes,
you will
sir.
get the. So you have to consider the concept of geometry, trigonometry.
Second చూద్దాం.
Are you getting the screen properly?
Yes, sir. Yes.
Okay.
Second చూద్దాం.
Fine.
Yes, sir. Yes. Second చూద్దాం. Done, sir.
Done. Okay. So on this, there is one question. Here they are asking, find the position and the nature of the image. Find the
Yes,
position
sir.
and nature of the image. Now, here is the object. So from the ray from the object are like this. Okay, ray from the object is like this. So means what is n1 and n2 here? N1 is the refractive index of the medium from which the light is coming. So N1 here is equal to 1 and N2 here is equal to 1.5.
Yes, sir.
Because light ray is going into the glass, so glass will be taken as N2, 1.5. And what is U, object distance? U is this 30 centimeter, and you will take it minus 30. Why you will take this minus 30? Because you will measure the distance in the opposite direction of the incident light from the object.
Yes, sir.
It is minus 30 centimeter, and radius of curvature is given. So radius of curvature you will measure in this direction. In this direction you will measure. So it will be positive. So radius of curvature will be 10 centimeter. So now you can apply the formula N1 by V minus N2 by U is equal to N2 minus N1 divided by R. Put all the values. N1 is 1. V we have to find.
Yes,
minus
sir.
N2 is 1.5. N2 by U. U is minus 30 is equal to N2 minus N1. N2 minus N1 is 0.5.
Yes, sir.
Radius R is 10 centimeter. So when you will find the value of velocity, you will not velocity, image distance, you will get plus 90 centimeter. Okay, plus 90 centimeter. So plus means image is formed somewhere here. Okay, image will form somewhere here. How? Earlier I told you the light ray from this object is straight like this, and another light ray from this object is supposed like this. Like after refraction, it will bend towards the normal.
Yes, sir.
Like this. And you will draw the normal. Passes from the center of curvature. This is the normal, and here the image is formed, and this distance we have find it out as 90 centimeter. This distance. Okay, so here the rays are actually meeting, so image will be real and inverted.
Real and inverted.
Okay, please note down. So this formula will be used in this way to solve the numericals.
Yes, sir.
Okay, Harsh, after noting this down, na?
Yes,
So
sir.
this is the last topic. We will meet in the next class with the new topic. Okay.
Sir, are you keeping extra class?
I will see according to the schedule. Then I will inform you. Okay, accordingly.
Yes, sir.